Okay. So for in last 2 weeks, what we have learned is in their basic concepts of Python. So to get started, we initially studied about how the computer works. So this there are three components that we need to keep in mind in terms of memory and execution. That is hard disk, your RAM, and CPU. So this is what we are trying to play around with. And then we learned how do we allocate memory using data types, basic data types. So it is asking for some sort of memory chunks from RAM. So we did that. So there are several data types, and there are two kinds of data types in terms of readability and writability. It's called immutable and mutable. Immutable is read only, and mutable is you can read and write. So examples are read only. We have um, tuples, and dictionaries keys are read only, and values are um, you can read and write, because if you are able to remove the change the keys, that means you're changing the indexes, which is not correct. So yeah, so that is examples of tuples and mutable lists. And we have yeah, hi, good morning. Yeah, Prash. Yeah. Yeah, so and also we have basic data types like there is integer, there is float, and things like that. And you can convert from strings as well. Strings comes into read only. Yeah. So and then we also learned in some place where we can convert string into a integer, like using in like while we were studying input function. So we did that. So this is called type conversion. And we also looked at how data types can be embedded within each other. So you can have a dictionary, uh, a key, and then you can also have a list. And probably within this list you can have a set, and within this set you can have like um, integers and probably different items, strings, and so on. So these are the things that you need to remember in data types. And later we looked at various other things like if else conditions, and then loops. So loops, important thing to remember is when you loop through an iterable or iterable uh, for in some iterable. So this element is the element itself, because we don't need indexes, because the languages which we learn in college or schools, what happens is we use indexes, and then we access the element because it's called an array, and then using indexes we do that. But that automatically happens. The idea of using indexes is to get those elements. So I can do something like a of I, and if I have I as 0, it will get the first element. But here we get the element itself. So you don't need an index specifically. In case you want indexes for something,
నేను పనుకోమని చెప్పినట్టు
and then you can use enumerate function, where you can enumerate an iterable, and it will give you indexes as well. So basically it give you a number, uh, and then you'll have whatever the elements it has, and so on. So that is about loops, and you don't have to worry about the ending condition, because all
మనం మీతో రాపించుకో చిట్టు క్రీమ్ వీడికి
and yeah, that's about loops. We also looked at variable scopes and modules and packages, and functions. Functions, just remember that def is a keyword, and you have your function name, and then you have some code here, and also you can return some object um, inside from this function, and you can also pass arguments a, b, c, and so on. And you can also have some arguments which are by default, they are called as default arguments, like c is equal to 0, and you can call those functions, and you can call functions inside functions. um, and if you just call the same function within the function, it is called a recursive function. You can do that. So if there should be some sort of breaking out condition in such cases, but yeah, technically you can call that, and you can also call some other functions, like factorial and os dot something and so on. And this levels of functions calling can be like anything. So how this, when you remember the function, you also should remember how this works inside the memory in the program structure. So when you call a function, it gets into stack frame, and when you call a function within this, so this this particular frame from the stack does not get out of this, we do not take this out, popping out of the stack. So we call, say I'm calling for a factorial, I can, it goes like this, and if there is any more function within this function calling, so it stack grows up. And we saw that if there is some problem at some point of time, say I'm trying to access a file which is not there, um, some os dot something like that, and then if that file is not there, what happens is it breaks here, and it throws all of this stack trace. So this is, it will just dump all this, which is called as trace back in Python. So it helps us to track from which, what is the flow of the, what was the flow when uh, this particular problem occurred, because you can have multiple flow, right? So if you start from somewhere, you can have t- like like this, you can keep calling functions like this based on if else conditions and things like that. So if something fails at this point, uh, you don't need all of other things, like this part is not required, this part is not required, so it should trace back from here to here, simply here. So this is why it is called as trace back. So that is something which you need to remember. And we also looked at user inputs, so which is just one function. So the output from this function is always a string. You need to type convert, uh, or it's also called typecasting. So if you are passing an integer, for human eyes it is integer, but for program it's a string. You need to uh, take this particular variable and convert it to integer. So we also looked at JSON file and how do we parse it. And so basically all these are from the memory point of view, it's a tree structure. So you have some root and you have children um, branching out. And again, these children can have multiple uh, nodes. So this is child node of this root, and this is child node of, and so on. So this can be how we realize in Python or JSON is, in JSON we put that into a dictionary, and then we put those root element here, and then use that as a key and children as values. Similarly, in XML, what we do is we do the same thing. The structure is the same. We do root, and again we uh, do something like um, child, and then we put value here and enclosing tags. So same structure, we are realizing it different ways. In fact, in YAML, it is like this root, and then there is tab or few spaces here, and then it goes on like this. So that's about structured data type. So those are all used in configuring something. For example, if I want to configure this mouse, I can say that what should be the LED power that it uses, and then what should be the initial starting condition. Because whenever you switch on the computer, the mouse pointer is, points to probably middle of the screen. And what is the speed of this scroller, and what should be the right click button, what should be the left click button, what should be the action of double click. So with just this one mouse, I can go on like configuring, say, 20-30 attributes. So how those things are stored, those should be stored is using a structured data. So or else it's difficult to parse for computer programs, right? So that is why they're used in most of the times it's used in one is configuration, storing configurations. Second thing is interchanging data from one place to another place over the network. So those are also called as data interchange formats. So because the program which is running on one computer it could be designed in or written in C, another computer who is sending in, so it could be Java, somebody else who is consuming it could be in Python or yeah, Fortran, whatever. So regardless of these languages, I can exchange these files over the network and parse it as I want. A good example is your mobile phones, where you can you're texting using WhatsApp, Telegram. So probably they are all using similar structured data. So that's about that revision of those classes. And we also learned about modules and packages. Modules, just remember, things to remember in modules is module is just a file, and within which we have functions. Additionally, if you have written classes, it will have classes and um, those objects. So whenever you invoke the how do you invoke or how do you import those modules is using import function, sorry, import keyword, and I can use say tests without .py, and all the it starts executing from line number one. So that is something which we need to remember, and we learned how do we uh, stop that, like how do we say if there is a function here and then you're inside your test.py, you are calling that function. So if you just import tests, what happens is it will invoke this function, right? So how do you stop it? You should be able to trigger it when you run on the command line, like Python tests. You should be able to do this, but you don't want to run when it gets imported. So that is using if double underscore name is equal to double underscore main. So this is one of the concepts you need to remember in modules and packages. And packages are nothing but folders which contains this modules. So you can have test.py and math.py and so on. And you can have multiple uh, different modules. And remember that this structure comes from the design and the architecture. It should match with that, or else it's difficult to. So somebody, if you're jumping into reading code directly, it's difficult to. It will be difficult if it is not organized properly. So it will give a hint about how the code is structured. And usually, what we do is whenever you want to learn about some module, you look at a diagram which speaks about it. Generally, those diagrams are called as design diagrams or architecture diagrams, and then try to translate that into like code. So after you read that and come to code, if it is organized, you kind of relate, okay, this is how the data flows inside that function. So that's about packages. So we discussed about exceptions as well. And yeah, that's about the overall last 2 weeks revision. And this week we will start with project. So before that, there are some concepts which you need to know. So today we'll cover those. Um, like we'll cover context managers. Uh, we don't need to go deep here because it's quite a little bit complicated compared to what we have studied as of now. So it takes a lot of time to get write complicated context managers, but we will look at how it works and how do we write your own simple context managers. And we will also study something about inbuilt libraries. So I'll show you some examples, but there are so many inbuilt modules, and what are their uses. So we will try to cover these two, and if time permits, we can cover more. Okay, so I'll clear. If you have any questions, please uh, feel feel free to reach out. Do not hesitate. Okay, so let us get into context managers and what it is and why do we need it. Okay, so I'll just open a plain Python file. So when do we need to use context managers, and what are these? Why is it called as context manager? So as we program, so the basic idea about programming is we are trying to manage resources, right? So what are resources in our case is one is memory, and there are peripheral devices, there are network devices. So when you connect a NIC card, which is part of your motherboard, so that NIC card itself is a peripheral device for us, for the CPU. And when you connect the mouse, it is again a peripheral device, and so on. In fact, hard disk is a peripheral device, right? So on top of the there are files. When we talk about hard disk, there are files. So in order to manage these um, resources, we should have some sort of initialization, and we should have some sort of cleanup. So initialization generally is if you're writing your own device drivers, that's a different story, because you have to know uh, the proper structure or a bit level knowledge about that particular device. But in general, for example, if you are dealing with the files, we are not dealing at bit level. We are dealing at we understand what a file is. So file is just a stream of bytes sitting on the hard disk. We retrieve it. How it gets retrieved, we are not bothered, because that is done using operating systems, and then an operating system will give you in a way that you can start processing it. And but operating system doesn't know when to close it. So it doesn't it's not aware. It just does what you say. So you ask for opening the file, it opens the file and gives a opening file is nothing but your hard disk rotates, and then it points to a certain place where the file is stored, a stream of bytes is stored, and gives a pointer where you can start reading from that byte. So it happens so fast that we don't come to know. So when you do file descriptor and do read lines, so the disk starts rotating. That is with the old disks, but nowadays we have different memory devices. So that works in a different way. But you should know that we are trying to access bytes which are connected via some cable on the disk on the computer. So once it rotates, so it's a costly operation. So operating system knows that, okay, I have given that, so it has given, and it doesn't know when to close. So when you uh, leave it just like that, for example, I will open a file and say some file. I'll give the complete path, say some path, okay. Path, say some path. Okay. And then if I do, uh, I can store this in FD, and I can do a lot of things here, like FD dot read lines, read. Um, there are several other functions you can use. And then if I forget to close it, what happens is that file is still open, and by accident you can overwrite it, or somebody else can do something and it can get jumbled, and there are so many risks related to that. So even though if those things doesn't happen, if when it this if this code goes out of context, that's still that particular open files, the list of the open files in the operating systems list will be still remaining open. So that will cause handling problems, like your um, uh, you are not, it's like we are eating on a dining table and we are just getting up and going up soon after that. So after usually in families we clean the dining table after we eat, right? So that is the basic idea of you cleaning up the resources once we use that. So proper way of closing it is we use close. So there is something called as close, and close does some internal cleaning up. So this is the right way to open a resource. Not this is not just for any files. This is true for network, and this is true for anything that you do deal with resources like memory management and so on. So this is how we do it. So sometimes the neat way of doing this is with um, some one- some file, some path as fd, and then you can do fd dot read or so many other things, and then you can keep on writing your own code here. So rest of the code. So you can see the difference between this and this. I'm not explicitly calling fd dot close here. So that gets handled with this particular keyword called as with. So this is more like you are getting a some sort of way to clean up without specifically closing it. So this is just about a file. We know how to close it and how to clean up resources using this close. So there could be other resources. There could be multiple steps to clean up the resources. So how do you deal with such things? So that is with context managers. And how does context managers work is actually quite simple. So we have read about, sorry, we have learned about classes, right? So let us see some resource. Okay. And within the class, we have learned that you can have some functions which are like inbuilt, they're inbuilt with. So those are like this double underscore, right? For example, I can have name, init, and so on. So if you have a function which can any object when you're not dealing with, we learned that we need to initialize it, which is called as construction, and we also need to so in Python, most of them when it goes out of when the object goes out of the memory context, garbage collector is another process within Python which cleans up the memory. But sometimes it doesn't know what to clean, like open files, it doesn't know, network, it doesn't know. So how does that work is using two functions called as enter and exit. So we can define those. Let me show here. Just I'll show you the syntax. So these are the two functions which help us to implement context managers, enter and exit. So uh, as I was telling you other day, so do not get directly jump into the code. You'll get sort of repelled by the logic because it takes some willpower to go through the logic. But to fight this, the trick is do not get into the code directly. Read the headlines, and then you can do like this. Or the read the class. A class is manager resources. We saw it. Okay, good. And then we are um, like fold this, and then you look at this. Okay, there are two functions. Now it's just one line of code. Now it's three lines of code, and you can open this. So now you don't have to remember what is in managed resources completely. You just focus on these two lines. So at the time you are reading only like one line and two line. Now I have one line. I have had just one line to understand. Okay, this is a function called as enter, and then you just have like two lines here. So that is how you read the code. It helps to go in an organized fashion. So you have two functions, which is enter and exit. And if you just define these functions and do something with this, which is implementation, and then you can use the class itself with keyword. So this particular keyword. So then it becomes just like the ones which we used here. So this is somebody who has implemented class called as open. Uh, he has written his own functions called as enter and exit, which will automatically close when it gets exit. So that is how that is why it's simple to implement it. Enter and exit. So just remember this. Okay. So this is about context managers, and you can write your own context managers just like this. So whenever you are dealing with such um, um, memory intensive code or network related code and so on, so you can use. So there is also something called as context lib module. So uh, it will give you a decorator, so which we will look at decorators in a while. So it will make any function as a context manager or manageable uh, code. So you can just use this import context lib and context manager, and then you can do at the rate decorate this particular function. So it will become a you can use it like this. It will become context manager. So there are two ways. So either you can use this or you can use this as well. Okay. So yeah, so the better is use this, because while implementing, you exactly know what you need to uh, do, and this is more readable. You don't have to use. Once you start using, the other people who are reading your code might have to dig even deeper. So this is best way to like define the context manager in class and then write your code. Okay, so that's about context manager. We have actually already seen this sort of code just a while ago. So this is how the context manager. It's cleaning up the resources, the basic idea of context manager. So yeah, that's about context managers. Let us look at um, decorators. So we looked at this particular syntax like ampersand and something. So let us understand what is a decorator, so that we can realize that in the code. Okay. So let me go here on a line. Let me come on at it. So when we say something as decorator, so what it means is so in real world, a decoration means we change the shape, or we change um, some characteristics of an underlying object, right? For example, if we so I was giving you like gift wrapping something or packing something, like you get an Amazon delivery, and then there is a box, and then inside that there is your product. So you're not changing the functionality of the underlying object, but you are trying to enhance that. Okay, so that is decorator. So in terms of Python, so what you can uh, uh, imagine is like there is an object, and there is some functionality built on top of this object. to do extra things. So something extra. So that is what is this decorators do. So how do we realize that is in Python, everything is an object. For example, your files are objects, which are nothing but as modules, and your folders are like packages. If you import it, it becomes modules and packages. Even functions are objects, functions, and classes itself are objects, and objects are, of course, objects. So everything is an object in Python. So it's Python is a 100% object oriented programming language, because if you remember, or if you know a little bit about C++ and Java, so there are some primitive types, for example integer, float, and so on. So those are not objects, those are like primitive data types. Why do we know that it's not an object is because there is no function inside this, inside integer. That's so it's just a memory. So if there is no function within that particular, nothing else, just the bits uh, that are only meant for it to represent an integer, so that is uh, an integer, so it just consumes some space in the RAM. But in Python, when you say int, so this is an object, and within this object, we have functions. For example, int may be having something like is digit, or is something like that. So you can do dir of int. You can it'll give you a lot of input, sorry, output. So saying that okay, there are inbuilt function, there are inbuilt variables, and so on. Some inbuilt default functions, and so on. So that is why in Python it is an object. Object means there is functions associated with that, which is nothing but operations, and the data itself. Data plus the functions will make objects. So that's about revision of object. So what it has to do with decorators is that functions themselves are objects. So these functions are themselves as objects. So functions themselves will have some additional functions where you can operate on top of it. So it will have data, and then it will also have some operations. So since this function itself is an object, you can actually pass this as a parameter. So if I have a function like def abc, some function, and return something, so say d, this is one function. So when I define this is an object itself. So abc will be some object. You can also, when you print, you can, it will become something like some function dot abc, something like this. In this model, this object is present. Okay. So you can pass around this function to another function. So I can use another function, which is maybe I will call it as wrapper, and I can send this as a parameter. Like I can send ABC as a parameter and do something, some logic here, and then call this function here, ABC. So and return. So what is happening is when I call wrapper somewhere else outside that particular context, out of that function, so I can call wrapper. So automatically now we know that this ABC also gets called. So what are the uses? So this is a basic uh, decoration, but we will look at one more level. So there is uh, another concept in Python where you can write define functions inside functions. For example, um, you can have a function like this, def function. and I can have another function defined inside this function. Define, say, function underscore something 01, something like this. And I can have one more function. So I think these are called as technically called as closures, I guess, because it's inside this. So this function is not accessible outside this module. So these are the two concepts that we need to remember before uh, understanding decorators. So now you can define your own functions, and also you can call functions as passing as arguments because those are objects. So out of these two, let us try to understand the syntax and let us try to understand how it works. So let me show you how it is realized in code. So yeah, this is whatever I said, it tells that. So now we understood what is how a function can be passed as an argument. Okay, so just this is the syntax. So you have a function, and then you have another function which is define another function, and you can call the function. So this complete thing is called as decorator decorator. And somebody who is going inside this function as an object, it is like decorated function. Okay, so I'll show you this particular thing how it works. So don't get overwhelmed, just fold it. So this is a function. This is another function which is defined inside. This is not getting called, this is just a definition. And this particular function which is func is getting called in. Okay, so that is the uh, idea here. So let us try to execute. The function is dot defined, so just remember that. So it has just uh, made a note that okay, this is the function definition, and let us see how it looks. So I have defined a function here, new function. Okay, and without this, let me just comment this. Without this is just a normal function, right? So say hello, hello. That's all. So when I decorate this, so this is syntax which when you add ampersand and do like this, so the Python interpreter searches for this particular um, name, and it looks that okay, there is something is which is already there, so I can call it like this. And this syntax is just a shortcut to remember this. So to do this, in fact, you can call this function and send it this as a parameter and do the same thing. But this is just a shortcut. So that is how the Python, one of the philosophies of Python, that it should be readable and you should not make people who are reading the code or dealing with code to get scared or something like that. So it's a simple way to do it. So to keep it simple, that's one of the philosophies. So I have a function and then it gets decorated. This is how it gets decorated. So additionally, what is the advantage? So now forget about whatever we learned about the decorators. So what is the advantage when I do this? So you can see that I'm doing something before and I'm doing something after. So this after and before and after is the capability that I get while using a decorator. So how do I make my own decorators is simply this. Define a function, define another function, just like you can name it anyways, and pass that function as. So why do you need this particular function is if you do not have this particular uh, lines of code and simply call pass this function, so you won't have an ability to uh, return the function itself. So when you return this, what gets returned is this particular function. It's not this function. You can see that. So this is just an execution, and this function gets returned. So that is the reason that this gets called and then it prints. So do not get just remember the syntax as of now, and then you can modify this code and write add prints, and then you can get try to understand more about this. But just remember the syntax as of now, because this can actually you can do write multiple decorators, and you can do something like decorators on top of decorators, like decorator 1, decorator 2, and so on. So when you do this, what happens to your function call, function stack, is that you are putting functions on functions so on onto the stack, and it gets unwinded when once you finish that job and it goes out of the context. So just remember the advantage and the syntax. So for now, just remember this advantage is you can do something before and I can do something later. So what are the interesting use cases is, say I want to print date or time at the time when the functions were called. So you can simply add, you can write your own function here, and you can write say some date time, and you can print date time, and you can date time as well. Print time. I'll give me a moment. Date time. Print current time in Python. Datetime dot now. This is how you print. So this particular function is gives us current date and time. So you don't have to remember. Yeah, just remember that. Okay, there is some library called as datetime. So let us try to do this. Now you can see that. So imagine that I have written this in a library, and you have a lot of functions which are you need to make calls, and in order to debug, or by default just for logging purpose, you want to print when this functions were called, so that you can track the time taken by those functions. So you can simply add this and you get all the benefits that is written inside this. So that is the power of the decorators. You don't have to, it's as good as writing your own class and doing all this, but it is very simple way to uh, do something before and something after. So just remember that particular thing. So one is syntax. You're passing the function itself, and you are writing your own function within, defining a function within this decorator. Third thing, you are calling the function, and you are returning this function which we have defined inside. So once you start writing your own thing, you'll start to understand so how this works. So you can like play around, like without this defining function, what will happen, and without specifically calling this function, what will happen, and without using this decorator, what will happen, and so on. So, but to understand the power of the decorators, you just you use it, define it, and use it. Yeah. So that's about decorator. So yeah, another use case is you can say you can write a decorator where you can actually now you have like this date and time, right? You can also calculate uh, so previous date here before calling the function and after calling the function. You can also print something like you can store this in variables and then do uh, if this is x is equal to date and time, and this is y is equal to date and time, you can do y minus x, which will give you the time elapsed to calculate or time taken for this function to finish. So then you'll have a decorator where you can calculate how long it took to um, execute. So that is one of the examples where you can use decorators. Yeah, so you can keep like there will be some sort of um, say requirements where there will be something before and after. For example, maybe you are reading a list of um, some file where it has you have a lot of email IDs, and then you take those email IDs, you do something before the email IDs. Probably you say want to add some sort of phone number or some sort of formatting, and after processing that, do some sort of formatting. You can use this. If I find this email ID, do this, some sort of logic. So you can use decorators. So that's about like very brief session about decorators. In fact, we can go on like 2 hours just studying the decorators, but just remember this for now. You don't require such a deep thing in decorators. Okay, so you can also use decorators with arguments because functions has got arguments, right? So this is how you can use. So when you pass the function, you just send the object. But how do we deal with the arguments is like this, args and quarks. So yeah, we'll look at this args and quarks when we do the project. So there is a lot of some small concepts which I haven't covered. It will be covered in the project. So these are variable arguments. Just remember that for now. So far we are passing only like three or two parameters inside the function, right? You can also pass variable arguments like for example, you want to send list of numbers. So instead of sending a list, you can say that 1, 2, 3, 4, and in next execution you want to send 5 arguments. So those are examples for variable arguments. So in such cases we use this sort of syntax. Args, they're called args and quarks. Args are arguments, quarks are key and value paired arguments. We'll look at that, so don't worry about this. So this is the syntax when you have when you're dealing with decorators which deal with arguments inside that. So one of the good examples they have given here is, yeah, uh, grid is just a function. So I am decorating with a function decorator called as a repeat. Again, it's a function. So I'm calling this only once in line number 14, but it gets printed thrice. Why it gets printed thrice is because I have a decorator which calls this function thrice or any number of times that I ask for. So this is how you deal with decorators which take in arguments. So yeah, once you start practicing it, you'll get used to that. But main thing is to remember something before and something after, and then the syntax. So these things. Okay. Yeah, that's about decorators, context managers, and we will I'll just start with command line arguments. So this is actually quite simple uh, concept. So command line arguments are, we have been using command line arguments so far. Like for example, you want to print list of files. I'll just do this ls on Linux. In Windows, we'll do dir, but it can also take, say, long listing. So this is an argument, right? So this is an argument to this particular function, not function, program. So how do you pass these arguments? I can use, say, like this to reverse the order. I can also use -t to the reverse according to time, or I can use simply ls-nrt, which is the same thing. So these are all called arguments, command line arguments. So how do I write programs in Python which can take arguments? For example, I can write, say, python.add.py and send 2 numbers. So how does this work? So this doesn't have any code at the moment, but you can send these arguments. So you can send even more arguments like. So what happens when we do? So probably I want to do uh, more specifically. I can give some controls like add say integers, add like integers, and add like strings, because integers get summed up if I probably use string as an argument which I have defined, and if I pass two strings, say hi, hello, I expectation should be those gets added, like concatenated. So you can do anything like so. This particular um, thing, the 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 one which we are executing in the shell. So remember that we are doing this on a shell. Shell is hosted by operating system. So this is your operating system, and operating system has a way to give you a handle to work with its resources. So operating system is developed for managing resources, and then user can get hands on top of it. So one of the ways is it gives you your user space, and on top of that, so one of the ways is it gives you a shell. So that is what we have opening a terminal. It is also called like terminal, TTY, and so on. So once you open the terminal, what happens is a process gets spawned. So we learned about processes in the first class. A process gets called process P1, which is a shell itself. And this process is waiting in a infinite loop. That is why it is able to take your orders or you take your commands, so that this particular process, which is a shell process, takes that, executes that, and finish that. So this particular code, for example, Python, when I type Python and do something, so this process spawns another process, P2, with the program name itself. Like program name will be Python. Now you can see that how many process we have spawned, right? So one is the shell itself. Operating system has spawned the shell. Shell has spawned uh, that the P1 process, and this gets executed. When you are executing, it is P2. Like you have now you have like three levels of execution. So processes. So this is like I think this is called a process zero, something like that, because it's a kernel, and this is a parent process. This is becomes a child process. So when this in Linux, when this gets killed, it gets owned by somebody else. So that is called as now like those orphans are gets owned by the its parent. So like that. So it works internally like that. So how do you manage these processes? So this becomes a process, right? So how does this get executed is because say this is our program. It starts with line number 1 and it ends with line number let's say 16. So it executes line by line and finishes that. And then this process dies. And again, this particular command line is waiting for your instruction. So because this is a different process altogether. So these are arguments are also called as like terminal arguments or command line arguments. Command line means nothing but it's a terminal. So that is why it is called as command line arguments. So how does shell come to know that there are arguments is because this is just a string uh, for terminal. So now there is a nomenclature or not a nomenclature. There is a uh, division of these commands. So division goes like this. Say, this is called as program name. So this is a base program in our case. So when you execute Python, the interpreter gets called. So here we have like one more level and then the program. So this gets handed over to the interpreter, and then we have this program running on top of interpreter. So generally we have program name and arguments. So there are just two things. One is the program name and the arguments. So how does this get into the operating system is? using something called as system level um, what do you call this? Variables, sys variables. You might have heard like sys variables, sys variables. Okay. So when you in Linux, you know that when you print $0, it gives the program name. So dollar star, I think it will give all the arguments. So dollar question mark gives the uh, output of what happened to the previous program on the command line. So what does this dollar mean is once you start with dollar, the operating system, which is Linux here in this case, similarly in Windows. So that those are all system variables. So this entire program or this entire command gets in as a system variable. So that is where it gets stored as um, system. So first argument is the system, the program name itself, the second name and so on. You can pass as many arguments you want, and so on will becomes argument for those commands. So that is how the operating system has defined a way to pass the variables around. So that is about little bit about Linux and how operating system gets variables from the terminal. So coming back to our um, example, so when we there is a okay when we pass something, as I was telling, this is the first um, string itself is a program name, and then rest of them becomes an argument. So if you do not have any libraries directly you are trying to lead, then it will be something like, you can see that this is a shell. So this is the process name itself. So $0 will give you shell name, and dollar star, you can see I have not passed anything. So let me try. So if you want to print something within the shell script, you have to write a shell script and write the program names, and you can pass this stuff. So let me just show you. Oh, let's see. Let's start. I need to say batch. There is something called as this. I was looking for this. So I have named it as just let's see what's happening. You can see that I just in this test.sh, I just wrote a shell function just to tell you how the arguments work. There is a I have just created program called as test.sh, which is a script, and it just has 3 lines, which is bin bash. This tells the shell that what program I need to use to execute this. So yeah, just do not focus on this. Just remember these two because it's a comment. Forget about this. Echo is like a printf statement in C, print statement here. Echo prints out something on the terminal. $0 is the program name itself. That is why I have got this when I execute it. So let us try to pass some arguments. Arg1, arg2. You can see that it has taken that, but it doesn't know what to do with that. So it just sorry, not this. It just print those arguments. Okay. Yeah. So the error that you just to clear out error that you got here is because we are using cat. Cat is not the program that we are trying to. Cat just cats are um, concatenate all the strings and then prints out here. So forget about this. This is what we wanted to do. We created a program called as test.sh. And how does operating system come to know that there are arguments coming in? So it takes in as that star dot, this particular statement is the one which gives you through which you will come to know that okay, these are the arguments. So this itself is this is just an invoking function because I'm creating another shell. So operating system, and then I have opened the shell, which is the current shell that you're seeing, or I can call this as TTY or terminal. So when I call this, it opens another shell for execution. And on top of this shell, this particular, so within this shell, not top of this shell, within this shell, this particular program gets executed. Exactly same as what we do in Python. Python, some your program name, prc.py, and probably some arguments. So at shell level, this is the program name itself, um, but it gets passed to the interpreter. So interpreter now makes this as first argument, and this as arguments. So that is how the operating system comes now that okay, these are the arguments I need to deal with. So it just becomes a variable at operating system. So it's up to the program to manipulate those. So there are some. This is one of the ways to get those arguments. So sysargv1 is the program name itself. Rest of the arguments like this in Python, but in Bash we just did this. This is the program name itself, which is nothing but test.sh. That is why you are printing this, and echo $* will print all the arguments, which is nothing but this, which is actually from here to here. So this is about understanding arguments, how this gets passed. Remember that there is like operating system, there is shell, there is somebody else who is executing a program. So there is levels of processes. So that is the reason that I spoke about processes initially, because if you do not know this internally, how it works, so it will you'll it's because to teach this concept it doesn't take 5 to 10 minutes. But if I just teach that, I won't be doing justice for your understanding, because I am trying to connect what you know already to what we are trying to study. So if there is no link between that, so you'll forget this, and also you'll whenever there is a requirement, you will try to avoid uh, using this because you do not know completely how it works, what is the connection at least, and you'll feel like okay, it's difficult for me, let us not do this and let me do something else to solve this problem. So that is the reason that you should always keep RAM, hard disk, CPU in the mind, and then the operating system. Uh, then there is process, the levels of process, how it gets executed. These things should be running in your mind. So you are like, imagine that there is a process in your own mind that has this particular structure, and whenever you execute this program, run through that process. Okay, this is how when I send this command, this all these things are happening inside here. So then you understand that okay, this is how it works. So that is about little bit about system arguments or the arguments, and there is a nice library where you don't have to do this. This is just to understand. So there is a library which helps us to write our own a nice way to define these arguments and control this. So which we will see tomorrow. And from tomorrow we'll start brainstorming on a small project, and then we will learn even more uh, further, where we can learn about how the process communicates within the, how do you split the modules, and how do you write projects in such a way that it is manageable. and you can add features on top of it, and we will increase or add more requirements and so on, and you'll get a um, knowledge about how to work with the projects, and how do we split that in our mental model so that it doesn't become difficult, or it doesn't feel like, okay, it's too difficult for me, sort of a thing. Okay, so yeah, just remember this. So this is about brief introduction about command line arguments. We will look more tomorrow. So now if you read the library, now it's easy to understand, because now you know how these things are connected. So it's easy. Yeah, that's it for today. So today I just wanted to cover these mini concepts today, so that we can start with project tomorrow. Okay, thank you for staying. It's 8:14. Yeah, sorry for overrunning. Yeah. If you have any questions, please reach out.